All right, so on to test 2 part 1 exercise 7 in Newton's laws. So we're given this inclined plane of 30 degrees and this block with a mass of 2 kilograms. It's saying to find the acceleration. Now, as a good point, always draw out your forces. So you have mg, perpendicular to the mg, you got mg cosine theta. Pushing back, you got sine was mg sine theta. Well, now you have if it's coming down, yeah, okay. And then you have your parallel to or anti-parallel to mg cosine, which is the newtons. Then you have a force. So it's going from here. So it's a force is being applied towards this area. Towards there. Anyways, okay. So it's asking us to find A is the acceleration. So A, what is our acceleration? So let's use the formula. F of x is m times acceleration. All right, so moving on, we're gonna end up with if we also take consideration of the sign, because being pushed on the force is gonna be mg sine of theta per negative, not positive but negative the force equals m times a. If we see both masses cancel out, so we end up with gram sine of theta minus f equals acceleration. So our is 9.8 sine go back sine of our 30 degrees minus the force, which is 15, and we get our acceleration. Our acceleration, when we figure this, is going to be 9.8 sine of 30 minus 15. We end up with negative 10.1. So that is our acceleration. So for part B, all right, so for part B, we have to figure out a force that when applied to the system, it will equal to 0. So we know if we draw again our inclined plane, we know we have a force of 15 and we have a force that is negative, and we have a force of being applied upwards of positive 5. So when we have so we have 5 minus 15 and plus an unknown force, but we know that it has to equal 0 because that's what they're asking us. The velocity is 0, acceleration 0, velocity is constant. So just basically solve for x. So when we have 10, it goes negative 10 plus f equals 0, so that force has to be a plus 10. That's